All right, this is Honors Algebra 2 Pre-Calc. We're doing 10.4 in Pre-Calc. We're going to do hyperbolae equations, and we're replacing the weird 1-second video that for some reason was on hyperbolae equations. Okay, so the standard equation of a hyperbola is written like this. So you'll notice this actually looks really similar to the ellipse equation that we saw in 10.3, right? A couple differences, okay? Number one, with ellipses, A is always bigger than B, right? A is the bigger of the two numbers. But here, A is the number, right? So here, A is the number that's under the positive, sorry, we're beach balling, that is under the positive one of these. See how that's A, right? And B, right, is the thing that's under the thing behind the minus, right? So B is the thing that's behind the minus, right? A couple other things. When we saw the relationship between A and B and C for ellipses, we saw that it was not the Pythagorean theorem. Well, here, the relationship between A and B and C is actually going to look exactly like the Pythagorean theorem, right? A squared plus B squared is C squared. So let's walk through this. So this first formula, right, with the x on top of the A squared, that's going to be a hyperbola that has branches that bend to the left and the right. Okay, so you'll see that here. This is a branch that goes to the left, to the right, and this is a branch that goes to the left, right? A hyperbola with the y squared, or at the front, right, the y minus k squared over the a is going to bend up and down, right? So the y squared at the front is up and down. So let's walk through how to find some of these equations, and then we'll kind of get a gist of how to go from there. All right, so first thing, the definition of a hyperbola is the set of all points in the xy plane, the difference of whose distances between two fixed points, focus 1 and focus 2, or foci, right, is a positive constant. So d1 minus d2 is a positive constant. So some terminology, right, we call these arms branches, right, so that's a branch of the hyperbola. Okay, the branch goes through the vertex, which is here and here, right, and then the focus, right, is going to be here and here, right? There's a center, and the distance from the center to the focus is called C, as we've seen before, right? And the distance from the center to the vertex is called A, right? And we'll talk about how we use the B in a minute. So this thing is called the transverse axis. Let's walk through writing some of these equations. All right, so we're asked to find the standard form of the equation of a hyperbola with foci at -1, 2 and at 5, 2, and vertices at 0, 2, and 4, 2. So you don't have to graph this, but I will put out there that it's a little bit easier visually to have an idea of what it looks like if you plot the points, right? So you don't have to, and I did a terrible job of, didn't bother to make this grid have any axes, but you get the gist. So you don't have to graph this, but it's a little bit helpful to know where things are. So the foci are at -1, 2, and 1, 2, 3, 4, 5, 2. Okay, so those are my foci, right? So you can find the center visually by recognizing that it's halfway between the two of them, right? So the center, you can either graph to find the center, and you'll find that it's at 2, 2, right? Or you could actually just find the midpoint, right? You could find the midpoint either between the two foci or the two vertices, right? So the midpoint would be -1 plus 5 divided by 2, right? You average the x's, and 2 plus 2 divided by 2. And so you're going to end up getting that it's 2, 2, right? So either way, that's how you get the center, right? So I can tell visually that C is 3, right? Because it's 3 units on either side of the center to get to the focus, right? I know that the vertex is at 4, 2, that's one vertex, and that the other one is at 0, 2, right? So I can see that my A is 2. So here's what I know. I know that A is 2 in the x direction, right? So here's the first bit I have. I have x minus 2, because that's one of the coordinates of the center, right? That's my h, quantity squared over 2 squared, because I know A is 2 in the x direction, right? Minus, and then this is going to be y minus 2, right, because of this k squared, over whatever b squared is, which we'll figure out in a sec, equals 1. So essentially, the hardest part of this problem is I really need b squared, right? So I need b squared. Well, I know that a squared plus b squared equals c squared for a hyperbola, because it's like its Pythagorean theorem, right? So I know that a is 2, so 2 squared plus b squared, and c is 3, so equals 3 squared. So I seem to get that b squared is 9 minus 4, or a 5, and that's all I need. So there's my b squared, and that's my equation of a hyperbola. So I didn't have to graph it, but it can be visually easier to graph it to get a concept of which direction things are moving, etc. So again, you weren't asked to graph it. if you were asked to graph it, you would actually make the little box around b that we're going to talk about in another problem. So I really just used this graph. So I wasn't asked to graph, but this is one of those spots where it's helpful to see A and B and C, etc. Right? So it's helpful to find those values. You don't have to graph, but that's the idea. All right, let's try an E1 the same way. Again, I'm not asking you to graph, but it's helpful sometimes to put stuff on the grid. So I'm going to do a terrible job of making my axes again. Certainly pause me if you want. So I have vertices at 2, 3, and 2, -3. So 2, 3, it's a vertex, and 2, -3. Well, again, same argument. You can kind of see by visual inspection that your center has to be right here, right? So my center kind of has to be at 2, 0. I can either find that by finding the midpoint of the vertices, or I can find that just by visual inspection, right? The next thing I notice, right, is that my A, right, so A is 3 in the y direction. Okay, so now I know some things, right? So I know A is 3 in the y direction. So I say, cool, y minus 0 quantity squared over 3 squared, right? Minus, and then it's going to be x minus 2 quantity squared over whatever b squared is, right? I need b squared, and that's going to equal 1. So I just need to figure out what b is. Well, in order to do that, I see that the first focus is at 2, 6, right? So if that's a focus, that means that c is 6, right? Well, that's all I really need, right? The other focus for the record would also be down here, but again, I need c is 6, so a squared plus b squared is my c squared. Well, a was 3, so 3 squared plus b squared equals 6 squared. So I'm pretty sure I get that b squared is a 36 minus a 9, so I think I get a 27. And honestly, I'd just leave it as a 27, right? Because it's b squared that I want there, not just b, right? So that's kind of the idea. All right, let's try another one. All right, so find the standard form of the equation of the hyperbola. Now this time, it's a little bit different, right? I'm not given the foci this time, so I'm going to have to figure out a little bit of other stuff. Okay, so here's what we know. Let's plot, again, I'm going to do my terrible axes. Let's plot what we know. All right, so vertices are 1, 2, and 1, -2. So again, I can spot that center, right? The center has to be at 1, 0. So, and I know that my A, right? My A is 2 in the y direction. Okay, so this gives me enough information to do some stuff. I have y minus 0 quantity squared over 2 squared minus x minus 1 squared over, I don't know, b squared, and that has to equal 1. Well, my argument is if I plug in an x and a y, I can find b squared, right? So this is going to be root 5 squared over 4 minus, this will end up being a 1 because it's -1 squared, right? So it's a -1 squared over b squared equals 1. I think I can solve for b squared. So this is a slightly different way to do this problem, but I think I get 5 over 4 minus 1 over b squared is, I'm going to go ahead and make this a 4 over 4 to make my life a little bit easier. When I subtract the 5 over 4, I get -1 over b squared equals -1 over 4. When I cross multiply, I end up getting -b squared equals -4. So b squared is 4. And again, I don't really care what b is, I just need b squared. So my answer is going to be y minus 0 squared over a 2 squared minus x minus 1 squared over a 2 squared, or a 4, doesn't matter, equals a 1. And that's it. So it turns out in this case that a and b are the same. And that's the deal. All right. Last one. Find the standard form of the equation of a hyperbola. All right, so same idea, right? So again, you don't have to draw it, but I find it kind of helpful because it just helps me know which direction my hyperbolae are bending, right? So my vertices are at -2, 1, and 2, 1. So that must mean the center is right here, right? So the center is at 0, 1. So here's what I know. I know that A is 2 in the x direction, all right? Well, that's enough to tell me that it's x minus 0 squared over 2 squared minus y minus 1 squared over b squared that I don't know equals 1. I'm then going to plug in x, y, and that'll let me solve for b squared. So when I plug in x, I get 5 squared over 2 squared minus, when I plug in y, I'm going to get a 3 squared over b squared equals 1. So I get 25/4 minus 9 over b squared equals, I'm going to go ahead and call this 25/25, right? So when I subtract, I'm going to get negative 9 over b squared equals, oh, sorry, I didn't mean to make it 25/25. I meant to make it 4. Come on, brain. Sometimes we have our moments. The common denominator is not 25. The common denominator is 4. Come on, Hogan, you had one job. When I subtract over here, I'm going to get a negative 21 over 4, right? So when I cross multiply, so that was negative, my bad. I'm going to get negative 36 equals negative 21b squared. So 36 over 21 is my b squared. And honestly, that's cool. You can leave it that way if you want. So my answer is going to be x minus, I think it was the 0. Let's go up. X minus 0 quantity squared over 2 squared minus y minus 1 squared over, and it's up to you. Like, you could leave this as just a 36 over 21. There's nothing wrong with that. You could flip it and clean it up and make this a 21 on top of 36. I'd leave it like this, though, and that's fine. Notice it's not squared. If you wanted to write it as a squared, you'd have to write this as this thing squared, right? Like, you could have also replaced it with the square root of that thing squared. And that's kind of the gist. So that's the hyperbolae equation video to replace the weird 1 second video that was lost.